Okay, this is a free response question on the second fundamental theorem of calculus, and this was question number 2014, number 3, that you had for homework, but we never got to. Okay, so this is what they gave you, and you need to find g of 3. So that means wherever there's an x, I'm going to put a 3. So you need that. So this means you want the area under the curve going from negative 3 to positive 3. So from negative 3 to positive 3. So it's going to be something like that. Okay, so we're looking for this area, and we're looking for this area in here. Okay, don't forget that one that's below the axis, that's going to be negative. Okay, so to do that, we're going to find the area of the big purple triangle first. That's going to be 1/2 base times height. And the base is this. So that's 5. And the height, let me erase this so you can see what the height is going to be 1, 2, 3, 4. So half of 20 is going to equal 10. So the area for this triangle is equal to 10. And then we need the area of this little triangle. So that's also going to be 1/2 base times height. So the base is just going to be 1. And the height is going to be 2. So you're going to get half of 2, which is equal to 1, but it's below the axis, so it's a negative. So 10 minus 1 is going to be equal to 9. And that was worth 1 point to do that. Okay, for part B, you're being asked when is G increasing and when is G concave down. Okay, so we need to know when are they doing both. Okay, so let's start with G. So G is increasing, so I'm just going to write this down. G is increasing when G prime is positive. Is positive. Or greater than 0. Remember, so if the original function is increasing, the derivative graph will be positive. So we're interested in when is G prime positive. Okay, we don't have G prime, we only have G, so we're going to find G prime by adding a prime to each side. And you will notice that this is the second fundamental theorem of calculus, so the whole thing just equals f of x. So if we're interested in when G prime is positive, we're really interested in when is f prime, when is f positive. Okay, so let me just erase this stuff on the graph. Okay, so when is the graph of f positive? That means when is it above the axes? And so that entire place. Okay, so that goes from -5 to 2. Okay, next we need to find when is G concave down. So the second derivative tells us about concavity. So if it's down, it's negative. So when is G double prime negative? That's the question. Well, we don't know about G double prime. We only know something about G prime. So we know G prime is equal to f of x, so I'm going to add a prime to each side. So what you do to one side, you must do on the other side. So the question is when is f prime negative? Meaning, when does f have a negative slope? Okay, so let's look at a graph of f. And when is there a negative slope? This would all be negative, and this would all be negative. So that is going to be in the interval from -5 to -3, and then from 0 to 4. So the question is, when would it be both of these things? So -5 is included in both. -4 is included in both. -3 is included in both. -2 is not. There's no -2 here. So it goes from -5 to -3. And then Negative 2 is not. Negative 1, no. 0. 0 is in both. 1 is in both. 2 is in both. 3 is not in both because this is ending at 2. So it's going from 0 to 2. Okay, so that would be the answer for B. Okay, for part C, we need to find h prime of 3. Before we could do h prime of 3, we have to find h prime. Okay, so we're going to do the derivative. This is going to be a quotient rule. So it's going to be the bottom times the derivative of the top, which is just g prime of x, minus the top times the derivative of the bottom, all over the bottom squared. Right, so 5x squared is going to be 25x squared. So that's h prime, and we need to find h prime of 3. So that means wherever there's an x, we're going to put a 3. So we're going to get 5, here's an x, times 3, so that's going to be 15, times g prime of 3, minus g of 3, times 5, all over 25 times 9, because 3 squared is 9. Okay, now we just have to simplify. So we have 15. So what is g prime of 3? Okay, so I'm going to erase this now, make some room. Okay, so remember from earlier, we know that g of x equals this. And now I want g prime. So we said that g prime is just going to equal f of x. So let's just write this over here and we'll keep it there. Okay, so we already did that before. So we're just recalling that information. So we need g prime of 3. So g prime of 3 means what is f of 3? So this is the graph of f. When x is 3, here it is. We're going to look down at the graph, and it hits it right here at negative 2. Okay, minus g of 3. Well, g of 3 we did in part A, and we got 9. And 25 times 9 is 225. Okay, now we'll do this math. Because, oh my god, it's a math class. And we get this. And this equals a negative 1/3. That was the answer for part C. Okay, and finally for part D, they gave you p of x, and they want you to find the slope of p. So that just means find the derivative. So this would be like a chain rule. So f of whatever is going to be f prime of that whatever times the derivative of the inside. Okay, so that's p prime, and we're supposed to find p prime when x equals negative 1. So that means wherever there's an x, we're going to put a negative 1. So a negative 1 over here squared is just going to give you positive 1 minus a negative 1, which will become a positive 1, times 2 times negative 1 is a negative 2, and then we have minus 1. Okay, so we have f prime of 2 times negative 3. Okay, so we need f prime of 2. So that means the slope of f when x is equal to 2. So here's where x is equal to 2. And so we need the slope. But what you might notice is that the slope along this entire line would be constant. So we just need to find the slope. So we have 2 points. We have this point up here, which is the point 0, 4. We have this point down here, which is 4, negative 4. So we could just use the slope formula, y2 minus y1 over x2 minus x1. And we get negative 2 as the slope. So f prime of 2 is equal to negative 2 times negative 3, and that equals a positive 6, and that was the answer.